Hi, everyone. Welcome to our Thursday and Friday lessons. So sorry if we missed you, and welcome back if you're just coming back to review what we went over. So our warm-up today was choose which of the following would finish the sentence. Changing the number of protons, neutrons, or electrons changes the name of the atom. Changing the number of protons, neutrons, or electrons changes the atomic number of an atom. And changing the number of protons, neutrons, or electrons changes the mass of an atom, but not its name. So the answers were protons and protons. The number of protons determines the name of the atom and its atomic number. Protons are key. And then the neutrons are what will change the mass of an atom without changing its name or its atomic number. So our POGL deadline was actually extended to next week, so Tuesday or Wednesday, whichever day I see you first next week, because we have a long weekend. However, I did ask for you to please hand in your POGL at the beginning of class. Once you hit that submit button, if you hit it again, you can choose to unsubmit your PDF so you can keep working. I want everyone to submit it today just so I get an idea of where you are, but then you're welcome to unsubmit and finish it up this weekend. And then there is a PEN chart. It's technically a quiz in Canvas, but that's also your homework to do over the weekend before I see you next. So after the warm-up, we took some notes, and any leftover time was spent for your POGL or your Gizmo, or if you were all done with both of those, you're welcome to start on the PEN chart homework. But we started with our original class Unit 1 notes. So we started with slide number 7, atomic composition. So this just kind of summarized what the POGL went through and what the electronic gizmo went through. So atoms are made up of protons, neutrons, and electrons. My nucleus has a positive charge because it has those positive protons and the neutral neutrons. So since it's a bunch of positive charges and nothing charges, the overall nucleus is positive. Most of the mass of my atom is in the nucleus. My electrons do have mass, but since it takes about 1,000 electrons to equal the mass of a proton or a neutron, they're almost considered to not have any mass. So we really only count the mass that comes from the protons and the neutrons in the nucleus. We round the AMU to say that each weigh 1 atomic mass unit. A neutral atom has equal numbers of positive protons and negative electrons. Therefore, there is no charge. Their charge is 0. They are neutral. And the number of protons determines the identity of the element, also known as the atomic number. So then this was a word bank, and all you had to do was click and drag to properly identify the diagram. Here in the middle is my nucleus. It's got those positively charged protons with the plus signs, the no charge neutrons, the orange ones without a sign, and then buzzing around on the outside, if you zoom in, you can see there's a little negative sign on those little circles. Those are my electrons. Then we took a quick moment to read a periodic table. So my element symbol for carbon is a C. My element symbol is just the letter, the capital letter, or the 2 letters, capital and lowercase letter. My atomic number for nitrogen is 7. That's the number up here in the top corner. Then we haven't really talked about average atomic mass. Right now, we're really just working with atomic mass, which is the mass of just one atom of one element, just the protons plus the neutrons. It's always a whole number. I never get a decimal. It's always a whole number. But my average atomic mass, that is an average of all of those atoms in the entire universe from what we can tell. So because that's an average, that's why we get those decimals. Now, the reason I'm pointing this out right now is that you're always going to have the average atomic mass on a periodic table. But that's not necessarily the atomic mass that you're going to be working with right now. Right now, we're just concerned about adding the protons and the neutrons. The atomic mass, or the mass number, is different from the average atomic mass. The average atomic mass is reported on the periodic table. That's the average for all atoms. But what we're worried about is the mass number, and that's just the protons and the neutrons in one atom. Then we went to the more Unit 1 slides. So this is the new version of slide number 9. This is very similar to slide 9 on the old version of the class notes. This one just has a few more things that the old notes didn't have. So here I wrote down that my atomic number is equal to my protons. That's always true. My electrons are equal to my protons if there is no charge. So if there is a charge column and it says 0 charge, then there's no charge and my protons equal my electrons. If you get a chart like this and there is not a column for charge, then that means everything in the chart has no charge. So unless there is a charge column, then you don't need to worry about the charge. My mass number is my protons plus my neutrons. Now you can rearrange these because these are simple equations. So if I have my mass, but I don't have my neutrons, I can just rearrange this, and my neutrons will be equal to my mass number minus my protons. Now, the new addition to this slide from the old version of the slides is this. My charge is equal to my protons minus my electrons. My positive charges, how many positive charges I have, minus how many negative charges I have. So the difference between those numbers is equal to my charge. But again, this chart does not have charge. I'm bringing this up because this was in our POGL. And so since this was in our POGL, I want to mention this in our notes as well. So then we went through some practice slides. So this is what your homework will look like. The first original version of it. There's no charge column. So all you have to do is take the information you have to find the information you don't have. So here I have that I had 89 protons and my mass number was 225. Well, if I know I've got 89 protons, then I know that the atomic number is also 89. If I have 89 protons and there's no charge column, then I know that my electrons are also 89. To find my neutrons, I take my mass number, 225, I subtract my protons, 89, and I'm left with 136 neutrons. Then I had to look up my atomic number. When you're looking up a symbol with your atomic number, I have a quick trick for you. Instead of looking at all of the numbers going across and just going back and forth with your eyes, it can get very tiring. If you have an atomic number and you're looking up a chemical, look right here in this first column. So it's not 89 is not between 1 and 3. It's not between 3 and 11. It's not between 11 and 19. It's not between 19 and 37. It's not between 37 and 55. It's not between 55 and 57. So instead of looking at that whole table, I know to go immediately and not start looking across until I get to 87. So 87, 88, 89 is down here. It's AC. So AC was my atomic symbol. Then I started here with MO, and I had 53 neutrons and a mass number of 95. Now I also have a suggestion on how to look it up when you have the symbol, but not the number. Usually, when I have an element, I'm usually pulling from these first two columns. Nope, no MO here. So the next place I'm most likely to grab an element for one of your problems is over on this right side. So look over here and nope, still no MO. So your third place you look is in the middle of the table. Let's see, start looking. Oh, there it is. Number 42, molybdenum. So I looked up its symbol, so its atomic number was 42. Since I know the atomic number is 42, I know that my number of protons is also 42. Again, there's no charge on this chart. So if I have 42 protons, I have 42 electrons. And my mass number, oops, this should be highlighted blue. If I have 53 neutrons and 42 protons, 42 plus 53 gives me 95 as my mass number. Now, when I post these on our Canvas classroom, I will have the rest of the answers here. This is up to you. If you feel like you need more practice, then I encourage you, you should finish filling this out. But this is your notes. You're in honors chemistry now, and part of being an honor student is recognizing when you need more practice. So I'm leaving it up to you that if you feel the need you need more practice, I'm providing that for you. All right, this is the new slide number 10. It actually is completely the same as the old slide number 10, but I felt it was more simple if I gave you all the new slides in a row instead of giving you a few random slides. So, isotopes. Isotopes are atoms of the same element, so they have the same number of protons, because remember, if you change the proton, you change the element, but they have different numbers of neutrons, so they have different mass numbers. So I have my 3 isotopes of carbon here, carbon 12, carbon 13, and carbon 14. All 3 isotopes of carbon have 6 protons, but each isotope of carbon has a different number of neutrons. Now, I also started talking about ions. Right now, we're still talking about whether or not we're going to be having a unit test for Unit 1 for Honors Chemistry. If we do have a unit test, ions will not be on it. We're saving ions for next unit. But since we did have ions in our POGL, I wanted to give you the notes about ions to make sure we all understand what's happening with ions and how they work. So ions are atoms with charges because they've either lost or gained electrons. The number of positive protons always stays the same. So this slide is entirely new. I didn't make a few changes. This slide isn't on your old unit notes at all. The reason is because we decided that if we have a unit test in chemistry for Unit 1, we are not going to test you on ions for Unit 1. But since ions played such a huge part in the POGL, I felt that you should have these notes to make sure we're all on the same page. So ions are atoms with a charge because they've either lost or gained electrons to become stable. Now, the number of positive protons always stays the same. I never change my protons. If I change my protons, I'm looking at something completely different. I can change my neutrons and still have the same element, and I can change my electrons and still have the same element. You never change your protons. Now, electrons are a lot like homework. How do you feel if you come into your math class and your teacher says, don't worry, there's only one problem for homework tonight? Then 5 minutes later, your teacher says, never mind, you have 20 problems for your homework. You now have a lot more homework. You're not going to feel very happy. You're going to feel very negative. And on the other side, if you go to math class and they say you have 20 problems for homework tonight, and then 5 minutes later, your teacher says, you know what, you only need to do 5, you're going to feel great. You're going to feel very positive. Electrons are like homework. When you lose electrons, you have a positive ion. When you have less homework, you feel very positive about your afternoon. When you gain electrons, you get a negative charge. When you suddenly gain new homework, you start to feel very negative about your afternoon. So electrons are like homework. Think how you feel when you have more homework or less homework. Of course, don't think about chemistry homework, because obviously more chemistry homework is just great. So think about math or English or any other subject. So here I had some examples. Why does this nitride ion have a -3 charge? And why does this magnesium ion have a +2 charge? Well, my nitride ion has 7 protons in the nucleus, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. I have 7 protons and 10 electrons. So 7 minus 10 is -3. Or you could see that there's a difference of 3. I have a difference of 3 when I count my protons and my electrons. I have more electrons than protons, so that's going to make it a negative charge. Then when I look at my magnesium has 12 protons in the nucleus, and then this ion has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So I have 12 protons minus 10 electrons. I have 2 left over. So I have a +2 charge. I have 2 fewer electrons than protons. And I'm very careful with this wording. More electrons than protons and fewer electrons than protons. I can change my electrons. I can't change my protons. When we start working more and more with ions, you're going to start to notice there are some patterns you start to recognize. That's all I'm going to say for that about now. And our last new slide is the nucleoid symbols. Now, this is very similar to the slide that's already in your notes, but I made some changes in some of those questions. So this was another word bank question, and you just click and drag it to be in the correct configuration. Z is actually shorthand for atomic number. You might see that on some worksheets. It might say atomic number and then parentheses Z. So the atomic number goes down here on my nucleoid symbol. My mass number goes above my atomic number on my nucleoid symbol. My element symbol is denoted with an X. The IUPAC, the people who are in charge of chemistry, who decide that carbon is named carbon and iron is named iron, they have designated that there shall never be an element X. So X is the stand-in for any other symbol. And then the top right corner is where we put a charge if an ion has a charge. If there is no charge, then we just don't write anything. Now, I did not take the time to go through these example problems in class, but they are really good problems. I'll probably use them some other time, maybe as a warm-up. So these are all the notes that we took. My recommendation is that you take these once you're finished filling them out. I've highlighted this slide, Control, Copy. This is slide number 9. So I'm going to go here to slide number 10 and paste. Do not link. So now I don't need that slide. Delete it. Now I have my new slide number 9. And I would do this for my new slide number 10. Copy. Paste. Don't link. New slide number 10. Old slide number 10. Don't need the old slide. New slide number 11. Paste. Now you won't have a ion slide in yours. I put this in there already for me. And then just replace each one. I think this is the easiest way to merge your two. If you're printed out your notes and you're doing this on paper, then just print them out and throw away the older ones. Or just recognize you'll have some duplicates. And we're done. That's all we did for our notes. Your homework this weekend is to finish your POGL. So it's still the same POGL from first class of the week, Atomic Structure POGL. Remember, I ask that you please submit it before you finish it and then resubmit it by next Tuesday or Wednesday. And then you have your protons, electrons, neutrons chart practice homework. Now, By the time this video is posted, there will be a second option. This original one, option 1, I'm probably going to call it 1 pepper or easy practice. There are no charges in this one. They're all neutral atoms. So if you're feeling kind of shaky about this, if you're not very certain about these proton, electron, neutron charts, use this one. And it's a fill in the blank. You just need to find what's the proper number of protons, neutrons, electrons to finish this up. Now, the reason this is a quiz assignment is after you submit this, it will tell you which ones you got wrong, and you can fix them until you get 100%. I want to give you 100% on your homework, so please, let me give you 100%. There is no limit to the number of times you can retake this. At a certain point, I will release the answers. Because it is fill in the blanks, Canvas is not very smart. Canvas is pretty stupid when it comes to grading your work. If the answer, I'll tell you right now that the number of protons for helium is 2. But if you enter it in wrong, what Canvas thinks is wrong, it might count it as wrong even though the answer is 2. So if you put in space 2, or if you hit 2 and then you hit the space bar, it might think that that's a different answer than just 2. So I will release the correct answers at some point. So don't be too upset if it says your answers are wrong. If it says your answer is wrong, then double check it. If you double check a wrong answer and you're still confident it is correct, then don't worry. Quizzes like this, when there are fill in the blanks, I will regrade it later. And because Canvas doesn't understand misspelled words, but I do. So if you have a misspelled word or a misentered number, I can recognize that it's the correct one and I will give you credit. So that's everything we did on Thursday and Friday. If there was time left over, I let you guys work on your POGL or work on that element builder gizmo. But that is it. I can't wait to see you again on next Tuesday or Wednesday. Make safe choices, and I'll see you guys next week.